Hi everyone, welcome to this Symphony tutorial. My name is Alice Chevrier and I will guide you through the different steps of the Symphony web app in order for you to model the digital twin of your energy system. Here you can see the different steps that we will go through. And one really interesting thing is after that we will optimize our energy system and we will get different results as to which systems are optimal in terms of cost and in terms of CO2 emissions. So this is an extract. I will go through that in more details later, but this is an extract as what you would get as an output. So you will see what solution has what emissions, what life cycle, how do you do, like what is the optimal design of your solution, etc. It's a very, very complete tool. So let's get started. So I will simply log in and create a new project. I log in with my account and create a new project. I give it a name, Tutorial Office with PV. Press enter, click on it, create an analysis that I will call analysis 1, and a scenario, the base case scenario. Analysis and scenarios are a way to structure your project and to test the impact of different parameters, for example. In this first step, now we are adding a hub. In our case, we only have one hub, which we will name Office Building. So we press on Add New and then we enter the name and we click on Add. What is a hub exactly? So a hub is a node on your site within which different energy conversion and storage technologies may be installed. So it means a hub can really represent what you want. So it can be a single building, it can also be a group of buildings or an entire city. Okay, so now we're already going to second step where we are defining our energy carrier candidates, which means they're the energy carrier which will possibly be within our site. An energy carrier can represent really any energy containing substance or medium, so you're fully flexible. If I click on Add New, I see that I have already a pre-selection. So for example, if I take electrical energy, electricity as a subtype, and then it's already pre-named electricity. So I have that, but I also have the possibility to choose some custom. So if I click here on the type and give other, I can enter some totally custom energy carrier and decide on the name on my own. But in this case, let's add our typical energy carrier. So we'll start with electricity because this is an energy carrier that will be considered when modeling a building for sure. Add new, let's add also some heating energy. I decide to go for heat 30-40 degrees in this case, and I click on add. We will also need some cooling, and therefore I add cooling. I decide to go with 10-20 degree cooling. Maybe one note is that there is no data directly linked to the type and to the subtype of your energy carrier. We will later be able to specify data, meaning cost and CO2 emissions, for example, for them, which means this could just be called cooling. This is really up to you. We added the temperature so that it's clear what range we're dealing with. I have to add new. I will have PV, and so I want to define also renewable electricity in order to be able to distinguish it from normal electricity. I will also probably consider installing a gas boiler, and so I have gas as an energy carrier. I will consider as well using a geothermal heat pump. In this case, it's not defined, so I will click on Other. The subtype will be custom, and here I can say geothermal heat, which creates the energy carrier geothermal heat. Now, if I'm thinking about using a heat pump, I will need to use the ambient air, and therefore I will also add the ambient air as being an energy carrier. As we have cooling, we will have a chiller, and a chiller rejects a certain amount of heat to the environment, which we also want to quantify and to model. Therefore, we will also add a type and a custom energy carrier, which we will call waste heat. I think we have everything for now, every of the energy carriers we want to consider. If it's not the case, this is not a problem. We can always go back to this step. Now let's move to the energy demands. Here we will define our demand. First thing to do is to click on Add New and to enter the different information that we are asked for. We select our hub, this is our office building, and our energy carrier. Let's start by entering our electricity demand. We have different way to upload an energy profile. Here's some information. The energy profile has an hourly resolution. So generally, either we generate a profile through our database, which is what we are going to do now, either we upload one from an Excel file, for example, with 8,760 values. We can also save our profiles and then reselect them later. In our case now, we click on Generate Profile, we select this and click here. This will lead us to our inbuilt database, and here we click on electricity as a demand type, and we select our building use, which is in this case an office. We have different way to create our hourly demand profile. In my case, I want to say that I have a building which was built according to the SIA standard 2015, and so I select that. Finally, I have to enter my energy reference area, which in my case is 10,000 square meters. I click on Next, and here I add it. And this is as easy as that. Now I already have my electricity demand that is defined. I have to do the same now for heating and cooling. I select heat, I generate a profile. Here, instead of clicking on electricity for the demand type, I click on space heating, and we do the same than before. Administration office, by building age, I look for my SIA standard 2015, and I enter my energy reference area, which is again 10,000 square meters. Add, and that's it. Now our last energy demand is the cooling, which we will enter. It's always the same procedure, it's very easy. Our administration and office, building age, SIA 2015, and let's enter our 10,000 square meters. And that's it. We already have defined our different energy demands. Now we're already done with step 3, and we're going to step 4, the solar resources. In this case, I realize now that I have not defined any solar resources energy carriers, and so I will do so. I'm coming back to the energy carrier here, and I click on Add New, and my energy carrier here will be solar irradiance. I select once solar roof, press Add, and in the second step I do the same, but this time I will select solar facade. So now I have two energy carriers which represent once the irradiation on the facade and once on the roof. When I mean on the facade here, I mean in this case on the south facade. If you had different facades orientation where you would consider installing solar technologies, you would have to define them separately. So let's go back to my solar resources. Now I can click on Add New and select my energy carrier. I will start with the roof and select my office building. In my case, I have 2,500 square meters of available area where some solar technology could be installed. Again, it's like for the demand, we have different ways of importing the hourly irradiation profile. We can upload it, again, easy with Excel if you have some detailed values, or we can generate a profile, which is what we are going to do. In our case, we decided that we're located in St. Gallen in Switzerland, and we select the roof, and we use our built-in database which already has the hourly irradiation for the location of St. Gallen for a flat roof. We click on Next and we add it. Now let's define our solar facade. So we click solar facade for the energy carrier, office building. We enter the available solar collector area, in this case 200 square meters, and we generate the profile. Still same procedure, click on Sengal, we choose our facade, and in this case, as I said, we have a vertical facade, so 90-degree tilt, source-oriented facade. Click on it, next. And that's it, we have created our solar resources candidates. Now we are already going to step 5, imports and exports. Here, first we will define our import candidates. This is imports, so for example, gas and electricity, but also on-site resources as geothermal heat or ambient heat. Let's click on Add New and start with gas. So we select gas as an energy carrier, we select our office building as a hub, and we enter our energy price, which we will, for now, we'll select 6 cents per kilowatt hour. Environmental parameters, let's click on it in order to enter our CO2 intensity, which will be 0.2279 kilo CO2 per kilowatt hour. That's it, we click on Add. Now we click on Add New again, we will import electricity. And we select the office building, again energy price, in this case we consider 18.5 cents per kilowatt hour, so 0.185. Again, you see here you have different parameters that you can enter for the cost, but for now we'll leave that to a quite simple cost definition, and we will enter our CO2 intensity, in this case 443 grams CO2 per kilowatt hour, that we have to enter in kilo. I click Add, and that's it. Now I have to add my on-site resources. We import them as imports because it's as if they're imported from the site. We take here our heat ambient, select our office building hub, and that's it. We press Add because in the case of heat ambient, this has no energy price and has no CO2 intensity. We press once again on Add New and select this time the geothermal heat for our office building. In this case also we won't give it an energy price or a CO2 intensity. Of course, if we model some, for example, a borehole system, this has a price, the system itself has a price, might have a CO2 embodied energy, well, has CO2 embodied energy that we may want to model, but this will be done within the supply technology that we will model later, not for the geothermal heat itself. So now we press on Add, and that's it with our import candidates. In our system here, we also want to define 2 export candidates. So I will start by adding as an export our renewable electricity. I select electricity renewable as an energy carrier, and as my office building as always. So here I can give the price that I would get when I export a kilowatt hour of renewable electricity, and I give it a price of 7 cents. In this case, I will not consider any CO2 compensation, but just so you know, this is also possible. And I click Add, and here it is. The second energy carrier that we want to export is our waste heat. In this case, so this will be we need to export it because our system needs to be balanced for every hour. So we have to do something with this waste heat, but also it's very interesting because it helps us quantifying how much heat we're rejecting to the environment, which is, for example, when we consider heat island effects, etc., is really important. So we press Add. We don't give it a price or an energy, CO2 intensity. Press Add, and that's it. We have modeled now our imports and our exports. And now we're going to the supply technologies. Step 6. Now let's start entering our supply technologies. We have 3 different types of technology candidates. We have conversion, which means it's transforming inputs into a specific outputs, or into specific outputs in the plural. We have storage technology, which are storing a specific energy carrier. And we have some technology package candidates. Basically here, this is a set of conversion or storage technologies that have to be installed together. So for example, we can within a technology package, we can install boreholes and a heat pump, the corresponding heat pump, and say to the program, these two systems must be installed together. In this case, I will not use the technology package candidate, but just so you know. So, also one other note is that we call them candidates. Why? This means that we will define here some candidates. It does not mean that the optimal solutions at the end will have these candidates integrated. It means that the algorithm will test whether or not it makes sense from a cost or from an emission perspective to integrate those technologies, which is why there are only candidates. So we have, again, different ways of entering technologies, either from the database or from creating custom. I will first create one custom, so we'll see how it goes, and then the other technologies that we want to integrate, we'll add them from the database. So first I click on create custom, and here I will create my chiller. So I give chiller as my technology name. Here I can see I have different optimization options, which means here we say it does not have to be installed. This is what I talked to about candidates, but we also have the possibility to say that it must be installed in one hub or in one of the hub. Here we have to select our hub, which is the office building, and then we will give a mode. A mode, as it's here explained, this is an operational regime of a technology. And it corresponds to a specific set of inputs and outputs. In the case of a chiller, we have as an input electricity, and we have as output cooling, but also waste heat. So here we select these energy carriers. We can also set a specific seasonal operation, but here we'll say it operates during all seasons. But this is interesting, for example, when dealing with heat pumps. So here I only have electricity as an input, so the fixed input share will be 100%. But as output, I have cooling and waste heat. So here I have to give an output efficiency, which is based on the primary input, and in this case, electricity. Let's give 200% efficiency for the cooling and 300 for waste heat. I keep going down and I will check my technical parameters. Here I am saying that the dimensioning of my technology will be optimized. I also have the possibility to give a maximum, for example, or a minimum capacity, and other specifications that I will now leave blank. Now let's give the cost parameters. First we start with the lifetime. In this case, I will give it 20 years. And fixed investment costs, which are in my case 23,476, and the variable investment costs of 938 francs per kilowatt. I can also enter operation and maintenance cost. In the data that I have some variable operation and maintenance cost per kilowatt per year of 22.9. So here the data that I'm entering, this is some data based on some research values. Of course, you can always adapt them as you want. I will not give a fixed embodied or a variable embodied energy, but CO2 value, sorry, but you can do that. And of course you can, one interesting thing is that you can save the technology. In this case, you will add this technology to your user database, and then the next time you just have to select it, and it's easy. But in our case, I'll just press add, and that's it. Here we see that I have inserted my technology. What happens where I insert the first technology is that I get a system diagram. Here we see on the right all the export candidates and the demands that we have modeled, and on the left the import candidates and on-site resources. Through defining the technology candidates, we define the systems that will transform our imports and on-site resources to our demands and export. So let's go up again. And now I will add my other system from the database. What do I want to integrate? I want to have for each generation a gas boiler. I want to consider that. So I click on it, select. Here you see that it says that I'm missing an energy carrier. This is because the gas boiler technology is per default set having an output of heat 70-80 degrees. This is no problem. I will click on yes. And I will then change my output energy carry that you see here. I will add my heat 30-40 degrees because this is what actually I want to have. And I will make sure that I set the output efficiency of my heat 30-40 degree to be the same than the heat 70-80 degrees. And now I will remove my heat 70-80 degrees. I should not forget to press here in order to set heat 30-40 as my primary output. This is quite logical because we have only one output, only one input, but here this has to be selected. Exactly, so all the other data are already pre-filled because we take it, I mean the cost parameters are already pre-filled because we take it from the database. And so the last thing I have to do in order to be able to press add is not to forget to choose my hub. Now it's selected and I can press add. I do the same again with other technologies. In this case, I want to add, for example, an air to water heat pump. I select it here. The output is directly heat 30-40 degrees, so this is perfect. I can just select my hub and select add. And so I keep on going. Now I want to model borehole plus heat pump. So I clicked on custom because it's a technology that I have the data for. What do I put? Geothermal heat as an input and electricity, and as output I do have heat 30-40 degree. Here now I have to give my fixed input share, it's in percent, but you can also give just a ratio, and we would say 300 geothermal heat, 100 electricity, and as an efficiency I would take a COP of 4. Here, one thing that is important, you see that my primary input is geothermal heat, but my primary input should be electricity because the primary input is the one on which the output efficiency is based, which means now the output efficiency of our heat 30-40 degree is based on the electricity input. 100 units of electricity will give us 400 units of heat 30-40. Let's keep going down. Technical parameter, will leave it this way, and we enter now the cost. I give it 20 years. My fixed investment costs are 35,657. Variable investment cost 2,490.7. Fixed operation maintenance cost 661.62, and variable operation and maintenance cost 4.75. That's it. Now I'm adding it. I want to add some other from the database, so the PV, for example, electricity generation. I have some facade installation, my facade PV, so I will click on it and on select. Hub office building. Here you see straight away it takes as an input energy carries the solar facade in this case. So I can add it. And now I want to add now my roof installation. In this case, I will just decide on the solar PV bigger than 30 kilowatts. I have to select my hub, and here you see it takes automatically the solar roof as an input energy carriers because this is what is defined within the database. Here, one thing that you can see is that we have a minimum capacity of 30 kilowatts. You could override that, but here I'm going to say that either it's 30 or more, either I don't have PV installed. Good. I click on add, and that's it. So now what I do like to do is to go down and to look at my system diagram and see if everything is well connected. So here everything looks fine. One thing that I notice is that the electricity that is produced by my PVs is considered renewable. That's what we set, but I see that there is no link between my renewable electricity and my electricity demand, which means I wouldn't be able to supply my electricity demand with renewable electricity. So in order to change that, I would add I'll add technology, which I will actually make it a virtual technology. It means it doesn't have a lifetime considered or price. And I will call it renewable electricity converter. I choose my hub, and then what I will just say is simply that electricity renewable can be fully converted to electricity. I leave the efficiency of 100, and I add it. And here I go down and I see now that it is connected. So everything looks great. One thing I'm still going to do is to add my storage technologies. So now I will add my storage technology candidates. I add them from the database. And I choose the generic hot water storage first. One thing that I choose my hub, and one thing that you can do is with the storage is to actually give a maximum capacity, because otherwise if you do not give any gray energy, it would have the tendency to dimension it to an extent that might not be realistic for the CO2 optimal solution. So I will give it 1200 maximum capacity. I add it. Now I add from database again. I'll add my cold storage. Here you see that it's asking to add a new energy carrier. This is because this is the same thing with the gas boiler. This is because this template of generic cold storage is given with the default energy carrier of cooling -20, -10 degrees. I will say yes, and again, I will just change that here. I give the hub. I give a maximum capacity as well. This time 800 I decided, and I add it. And the last one we want to add is my battery storage. Same, hub is office building. Here you see that the energy carries electricity, but in my case I want it to be the renewable electricity. And I give it also a maximum capacity, in this case 1000 kilowatt hour. I'm adding it. I'm checking one last time exactly my system diagram, and here what I see is that my generic hot water storage is not connected. It looks like it's storing an energy carrier that I have not defined, so let's go and check it out. We see it's heat 70, 80 degree, and exactly, so it's not an energy carrier that I have not defined, it's an energy carrier that is not linked to my system. And this is because, again, the default energy carrier of hot water storage is heat 70, 80, and I didn't get a warning because this is an energy carrier that I added before while I was adding the gas boiler. So I just changed that, and I save, and now everything looks perfect. So I can click and go next. So here I am in step 7, which is about modeling network links. I am not going to use this functionality now because I just have one hub, so I do not need to link hubs together. But just that you know, here you would be able to model some network technology candidates and network link candidates if you had many hubs that you wanted to link together. You would be able to set some parameters like losses per meter, like cost per meter, etc. So next step is then the step other. The only thing that we have to set here is the interest rate. And it's important because basically we are considering life cycle costs, and the interest rate will be taken into account in order to annualize the investment cost. So then we click on step 9, which is just a setup review. And if we are happy with our conditions and setup, then we just click on Finish Specification and Prepare for Execution. So now we're back here in the table with our scenarios and our setup, and we click on Execution. Here on Execution, we'll have to select which scenario we want to execute, so our best case. Here we see our objective 1 is minimizing our life cycle costs, objective 2 is minimizing our CO2 emissions, and we give the number of points we want in the Pareto front. This means the number of optimal solutions we want to calculate. I like to enter 4 here because this would give me 1, the cost optimal solutions, 2, the CO2 emissions optimal solutions, and then 2 solutions within those optimal solutions. I click on execute and continue, and now this is executing. If I go on results, I see here that it is executing, and what I will have to do is to click on refresh, and then I will see when the optimization is done. You also receive an email that tells you that the optimization is done. This will take about 3 to 4 minutes, so you can have a coffee and come back in 4 minutes and check your executions. I will just skip forward. Now here we see I skip forward and my optimization is done. So scenario is optimized successfully. What you might have to do on your side is to press on refresh here, and then you'll see the same message. So you can here download the inputs as an Excel. So it's all the inputs that you gave for the optimization, or also the output. But what we will do, and what is very easy, is to click here on view results, and we already have prepared a so-called results dashboard. Here you have to click on view. And so here we are on our so-called results dashboard. The first thing you can see here is this Pareto front. So it's the line with the optimal solutions. And you can see here that, as I said before, we optimized for 4 optimal solutions. The very interesting thing in this dashboard is that we already visualized a lot of the information. You can see for each of the optimal solution, you will see the lifecycle cost annualized. You can also see where are the investments used for, so for which technology. You can also check what's your optimal design for each of your technology. You can also, you have the capacity of your storage technologies. There's a lot of information. You can also have detailed information about a specific solution. And here you see, for example, the system diagram, which is dimensioned, and you have also this diagram. It's a Sankey diagram. So that's it. I'm not going to go more in detail into the analysis of these dashboards. There will be a special video on that. But I want just to make us realize that we modeled a building within 30 minutes and we optimized it. I hope you enjoyed that. Thank you so much for watching.